Hi, everybody. In this video, I want to look at more examples of linear word problems, but these ones really focus on formulas. So in order to solve them, you need to know a little bit of background for each of these problems. So these are some of the main formulas we'll be using. The first one here is A equals LW, and that is the area of a rectangle. So in that case, its area is equal to length times width. So if you don't know that one, make sure, again, you write in those key terms as well. So L is for length here and W is for width, and those are being multiplied. The second one is an example of simple interest. So interest can actually get really complicated. You can think of interest if you have a savings account. You know how you get a little bit of extra money each month from the bank? That's interest. Or if you have a credit card or a loan, you have to pay interest, right, for borrowing that money. Again, it can get pretty complicated. So this is the formula for simple interest, where interest is calculated just one time, at the end of the year or something like that. So I is for interest here. P stands for principal, which is the amount of money like either in the loan or that you're borrowing or in the account. R stands for rate. So that would be the percentage rate that the interest is earning as a decimal. And T is for time, which is typically in years. The next one is the perimeter of a triangle. So here A, B, and C are representing the different sides of the triangle. But the big idea here is that for perimeter, you just add up all the sides. It doesn't actually matter the shape. If your shape is a rectangle or an octagon, you just add up all the sides, and that gives you the perimeter. Next one is for distance. So this formula is distance is equal to rate times time. Rate is like a speed, so how fast something is moving. So if you see an example that starts talking about speed and distance for things and time, then this is going to be the formula you're going to use. The next one, V, is for volume of a rectangle. So it's length, width, and height. I guess it's really not a rectangle, right? It'd be more like a box because it has 3 dimensions here. Sometimes we'll just say of a rectangle there, but it really is a rectangular solid. Let me write that in. 11. Right, so some sort of solid, like a box, that would be your volume. And then the next one is actually the same formula. One is given as a fraction, one as a decimal, but this relates degrees in Fahrenheit to degrees in Celsius. So this is one of the formulas. There's a couple of them that we can use to go back and forth between those two forms. So I'm going to show you a bunch of different examples here that rely on formulas in this section. So the first one, and again, I have copied this down already. So if you need to pause the video, go ahead and pause it. And then you can take this down and then come back to it once you have written it and read through it a few times. So don't forget, we're going to use our same techniques. We're going to read through the problem a few times. You can underline or draw pictures or take notes, whatever is good for you. We're going to think about the goal of the problem and then probably define our variable. Now for this section, it's a little bit easier for that because we have formulas that we're using. So the variables are sort of going to be predefined for us, but you do have to recognize which formula to use in these sections. So it says a glacier is a giant mass of rocks and ice that flows downhill like a river. Portage Glacier in Alaska is about 6 miles or 31,680 feet long and moves 400 feet per year. Icebergs are created when the front end of the glacier flows into Portage Lake. How long does it take for the ice at the head or beginning of the glacier to actually reach the lake? So a couple of things here. So our main question is, how long does it take for the ice at the beginning of the glacier to reach the lake? So look at the question, how long? So you're looking about time here. So our goal is to determine some sort of time, right? Is this going to take a year? Is this going to take days? How long is this actually going to take? The other things you're going to notice is you do see two things. You see a distance. So the length of this is 6 miles or 31,680 feet. And you also see a speed, 400 feet per year. So I'm seeing distance, I'm seeing a speed, and I'm seeing time. And remember, speed and rate are the same idea. So rate we often use for speed a lot, or sometimes for percentages as well. So this one here is making me think that I should be using my distance equals rate times time formula. Now, this is our goal here, is to find how long it takes, right? So our goal here is we're looking for the time. So our time is going to remain the variable here. So we're going to let t just stay as time. And then we're going to have to fill in the other two pieces of information. You do want to watch your units. Notice how the rate is given as feet per year. And then for the distance or the length of this glacier, for it to actually get from one end to the other all the way down into the lake, it's 6 miles or 31,680 feet long. Now you want your units to match. So I'm going to have to use the feet one so that it can match. So my distance here is the 31,680. My rate is the 400, and I do not know the time. I'm going to go ahead and divide both sides by 400. And when I do this, I get 79.2 for the time. Now think about this. Our rate was feet per year. So the time must be in years here. So again, your units should match throughout an equation. So you do want to be really careful about that. So our answer here would be about 79.2 years. Right, so here we had to recognize, again, we had a very specific problem that has a formula that's already established for it. So if you see things with speed, so that's rate, time and distance or length, something like that, then you're probably using this distance equals rate times time formula. And again, the main formulas I've given you are going to be the main focus here. So I know there's lots of the formulas that could be used, but these are some to get you started. All right. A botany student is allowed enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of his garden must be 30 feet, find the length. All right, so here we can see we have a rectangular garden. This is a great one to draw a picture. We're putting a fence around that garden, right? The perimeter is 140 feet. So remember, perimeter is all the way around the edges. So your perimeter for any shape is always the sum of all the sides. So we're adding up all the sides. It doesn't matter what kind of shape it is, as long as it has sides, right? So not a circle, but anything with sides, like a triangle or a rectangle, pentagon, hexagon, octagon, it doesn't matter. The perimeter is always the sum of all of them. So you go around the outer edge. So the perimeter we know is 140 feet. So the whole way around. I know the width has to be 30 feet. And if it's a rectangle, the widths would be the same, right? Those two sides would be the same. And I do not know the length. And you can see my goal right here. So my goal is to find the length. So I'm going to just let length, you can let it be X here, or you can let it be L, right? We can use L for length here as well. The width I actually do already know. So the width is going to be 30. And those are the two parts of the rectangle that I need. So again, how do I figure out this formula? Well, it's the idea of perimeter. So I'm going to add up all the sides. So I would add up a 30. I'm going to just stick with X in my picture and X, another 30, and another X. And the total of that has to be 140. Now, a big caution here with perimeter is a lot of times when students see things like squares or rectangles, they forget to do all four sides. They'll just do one of each. So they'll just do 30 and the X, and they'll forget to add in the other two sides. So for perimeter, you are going all the way around. So all of those sides need to get added in. For rectangles, you could also use the formula twice the length plus twice the width. And again, that's just for a rectangle. So that also works if you've seen that before, or like I said, you can just add up all of the sides. So now on the left, I have a 2x plus 60. I can subtract 60 from both sides here, and I'm left with 80. Divide by 2, and I have x is equal to 40. Now, again, that was my length here. So the length is 40, and everything was in feet. So we're going to match that feet. Now you can check this one. So if I add up 30 and 40, I get 70. And then another 30 and 40 is another 70. So 70 plus 70 is 140. So this looks good. So this seems to check out fine. I have another rectangular problem here. So geometry problems tend to be really popular. Not that you have to do just those, but they're kind of fun to work with because you have nice pictures you can draw. It says the length of a rectangular road sign. So I'm just going to draw a quick rectangle here. So the length is 6 inches less than twice its width. And we're going to find the dimensions if the perimeter is 204 inches. So again, what is our goal here? So our goal is to find the dimensions. Now, dimensions would mean length and width. Right? So it depends on the problem, but a lot of times it's going to be length and width for your dimensions. Now, if I read through again, I see that the length is 6 inches less than twice its width. So 6 inches less than twice the width. Actually, I'm going to leave a little bit more space here. Let's put the width down here. So if I read this, I see there's no information about the width, but I do have something about the length. So what I'm going to do is I'm going to let the width be my X, or again, if you want, you could use W. It doesn't matter to me. And then for my length, I'm going to write it using the width as the variable. So twice the width, we'll use W here. How about that? 2W, and then 6 inches less than that. Remember that than is going to switch the order. So we're not going to do 6 minus 2W. We're going to do 2W minus 6. So it is important to watch out for those little keywords like than or from, which may reverse the order. So our width will be W, and then our length is twice W minus 6. But we still have the same idea of that perimeter being 204 inches. So we're going to add up all 4 sides. So I have a W, 2W minus 6. I have another W, and I have another 2W minus 6. And all together, that would give me 204. All right, so let's see. I have 3, 4, 5, 6W minus 12 equals 204. I can add 12 to both sides. I get 216. And I can divide by 6, and I have 36 here. So my width is going to be 36, and notice that everything is in inches, right? So if I go back and read here, I see inches here, I see inches here. And then for my length, it's going to be 2 times 36, and then minus 6. And when you get that, you should get 66 there. So my length is going to be 66 inches, and my width is going to be 36 inches. And of course, you can check this if you add up 2 lengths and 2 widths. So going all the way around for the perimeter there, you should get 204. So again, you can always check your work. And I do encourage you to just, again, give it a quick check. So add these all up, make sure you're getting 204, double check, is this actually twice that minus 6, and make sure all of that checks out. And in this case, it does. All right, I'm gonna do one more example here, mix it up a little bit. So this one, we're using the formula for Fahrenheit and Celsius. So it says the average temperature for September in Frankfurt, Germany is 59 degrees Fahrenheit. Find the equivalent temperature in Celsius. So there's our goal. In degrees Celsius. Now, if you see Fahrenheit and Celsius, you're going to go back and look at that first page, and there is a formula that is given to you, which looks like this, or there's one with a decimal. So again, we're going to let C equal the degrees in Celsius. So we're just going to use the same variable here that the formula is using. Now I'm going to use the fraction one. But I encourage you to also try it with the decimal and make sure you get the same answer. So it is fun to, again, verify that both of them do work. So what I know here is I know my degrees Fahrenheit is 59. So I can plug that into my formula. And then I can go ahead and I can solve for C. Now, there's different ways to solve here. I tend to like to always clear my fractions first. So I see a denominator of 5. So I'm going to multiply everything by 5. Now, you do have to multiply both sides by 5 here, or all parts, in order to keep this balanced. So I can't just do the 9/5. I have to do all of it. But when I do that, I can cancel that 5 out. And then now I have, let's see. Let me see. Well, let's just write it out. I came to the table without my calculator, so that's all right. We'll just do some quick math here. So I do 5 times 59, and there I'm going to get 295, and I do 5 times 32, and again, there I get 160, and those two 5s are going to cancel. So I'm going to subtract 160 to both sides now. And I have 135 is equal to 9C, and now I divide both sides by 9. Now 9 goes into 13 one time, and I subtract and get 4. Bring down the 5, and that goes in 5 times. So I get 15 even here, and that would be my final answer. So I have my degrees in Celsius is 15. So 59 degrees Fahrenheit would be the same as 15 degrees in Celsius. And again, try it with the 1.5 in there as well. If you use the 1.5 instead, or sorry, 1.8, I'm sorry, 1.8 instead there. So let's see. You have 59 equals 1.8C plus 32. Now you could clear your decimals here as well, although this one's kind of simple. It's only one decimal point, so I actually would probably leave it in and start by subtracting with the 32 on both sides. So here, let's see, I get a 7 and a 2. And then because you can use your calculator, you can just divide by the 1.8. So this is one where I probably wouldn't cancel my decimals because it's a relatively simple decimal and it's just one of them. But I would definitely use my calculator, and you should also get 15 here. So go ahead and give that a check at home on your calculator and see that both of them do work.